Go- Good afternoon, students. So I'll be discussing the physical symbol system hypothesis of artificial intelligence. So starting with, I would like to discuss the underlying assumption for this. So here, the physical symbol system hypothesis is actually was given by Newell and Simon in 1976, which was the heart of AI research. So a physical symbol is actually the necessary and sufficient means for general and intelligent action. So the physical symbol system consists of a set of entities called symbols, which are physical patterns that can occur as components of another type of entity called an expression, or you can say a symbol structure, as it is here. So next, the symbol structure is again composed of a number of instances or tokens of symbols related in some physical way, such that one token being next to another will not create a problem. And these instances, if you take one at a time, is an instant. So at any instant, the time on the system will contain a collection of these symbol structures. The system also contains a collection of processes that can operate on expressions to produce other expressions, which is the process of, say, number one, creation, modification, reproduction, and destruction. So you will create the signals, you'll modify the signals, you'll reproduce the same symbols or instances, and you will destroy them also. So in total, a physical symbol system is actually a machine that produces through time an evolving collection of symbol structures. Such system exists in a world of objects wider than just these symbolic expressions themselves, and not just equations or adaptive equations that we normally discuss are there. So what we are having a physical symbol system, then expression or a symbol structure, instances, and these instances can be modified and so on. So whatever we have discussed today is just an hypothesis, but what these appear, you can prove or disapprove uh, these things on logical grounds. So it must be subjected to empirical validation. Now this empirical validation may be true or false. So the only way to determine is via experimentation. So computers provide the perfect medium for this experimentation, since they can be programmed to stimulate the physical symbol system we want. So this ability of computers to serve as arbitrary symbol manipulators was noticed very early in the history of computers. So this is why we use computers in AI mainly. So based on Babbage's work in 1842, what Lady Lovelace said in 1961, which is around 1 century later, is that she made an observation on this proposed artificial intelligence of Babbage and said that the operating mechanism can be thrown to action plan independently of any object to operate upon, although a course or result could be developed. Again, it might act upon other things beside numbers, where objects found mutual fundamental relationships could be expressed by those in abstract science operations, or it may be susceptible to adaptations and other things. So Lady Lovelace, what she tried to do is that she tried to get a computer based idea on the artificial intelligence that Babbage proposed. So uh, suppose for an instance that a fundamental relation of pitch, sounds of signs of harmony and musical composition were susceptible to such expressions and adaptations, the engine might compose a elaborate and scientific piece of music of any degree of complex in extent. So this is how this Lady Lovelace had imagined about Babbage's proposed artificial engine. So what she tried to say is that these experimentation validation that we are saying may be in any form. So what we can do is that it will become increasingly easy to build a computer machine, so that become increasingly possible to conduct empirical investigation of physical symbol systems. So earlier we used to use physical symbols, but later on these neural networks came, under which you have the deep learning, machine learning, and so on coming up. We'll go to that later. So in such investigation, a particular task that must be regarded as requiring intelligence is selected. So you can take any work for which you need some intelligence. So a program to perform the task is produced, and then that particular thing is tested. So it may be anything like, say, I know that 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, 4 square equal to 16, and so on. But this is a nonlinear equation. So if I am able to train a system which is able to find out that this relationship is of square relationship, then it has some intelligence. Although we can or we cannot have been completely successful in creating the programs that perform all these selected tasks, most scientists believe that maybe these problems that we are encountered will ultimately prove to be surmountable by some sophisticated programs that we are yet to come up with. So some programs we may find some intelligent solutions, some programs we may not find some intelligent solutions, so that will be time to time. Evidence in support of physical symbol system hypothesis has come not only from the areas such as playing, where we normally use these kind of things, where one might at some time instant some expect something and it will find, but also some areas such as visual perception, where it is more tempting to suspect the influence of subsymbolic processes. So here what the idea is that, just like if you have seen uh, Krish, where they initially koi mil gaya, initially there where they were sending some symbols to outer space, and then so the symbols that they were sending, this symbolic thing, if you open any old AI book, you'll see a lot of symbol reasoning and other things being applied. So these are some symbols that can be used instead of some numerical equations. However, the subsymbolic models, for example, neural networks, are bringing these changes, like beginning to challenge the symbolic ones, such as who were doing the low-level tasks and doing it in the new way using the neural network. So neural networks are normally based on some intersymbolic things, where certain subsymbolic models will conflict with the physical symbol system hypothesis, and it is still a debatable topic as per Smolsky in 1988. So uh, I will discuss that. Let's see. So there will be different things. That's it. So I will discuss these things in details, say in the later on classes. So what we have is that one interesting attempt is to reduce, say, human activity by understanding jokes. Like machines do not understand jokes, but human beings are able to laugh at somebody's joke and other things. So as per Claus in 1980, a book came up, Mathematics and Humor. So there they were analyzing whether machines are able to understand jokes or not. So it is of course possible that the hypothesis will turn out to be only partially true, but there may be some instances where you can apply these things. So the importance of physical symbol system hypothesis is twofold. Number one, it is a significant theory of nature of human intelligence. So it is of great interest mainly to, this is mainly interested to significant theory for nature of human. So nature of human intelligence, when say, so we may relate it to psychology, so it is of interest to mainly psychologists. And the second one is that it forms the basis of the belief that it is possible to build programs that are able to perform intelligent tasks like us, whether these things are related or not. So that is now these two are the main importances of physical symbol hypothesis. So we are having human intelligence parts of which are of interest of the psychologists, and the other part is whether they can perform intelligent tasks. So both are important, or both are related as well. So if you have human intelligence and you can perform intelligent tasks, so both can be related or not. So let's come to what an AI technique is. So if I come to the question that what is an AI technique or artificial intelligence technique, so artificial intelligence programs span a broad spectrum. So there are a lot of things that come under this artificial intelligence. Some may be very common and some may be very hard to deduce. So what maybe they may be having very less common things in between. One problem may be identifying whether the group of objects is a fruit or a play item, or then maybe another question where it may be asked to do some medical examination and assumption of medical diagnosis kind of thing, or it may be used in engineering, it may be used in healthcare, and so on. So let's come to some questions like the first one, uh, that are there any techniques that are appropriate for solution of a variety of these problems? Obviously they are. And what are they? They will be the neural networks, AI techniques, where if you can make a system or machine to learn, it can take care of this. Secondly, what then, if anything, we can say about these techniques beside the fact that they manipulate the symbols? Yes, they manipulate symbols, but they are coming up with an intelligent solution, or they are training themselves. So that is one of the way. And the third question is, how could we tell if those techniques might be useful in solving other problems, perhaps the ones which were not initially considered as AI problems? So these are the three questions which are into picture. So the properties they need to possess for the solving this are called the AI techniques. So last 3 or 4 decades, AI research has been dealing with the main fact that intelligence requires knowledge, or in our computer science terms, we said intelligence requires data. Means a system needs to be trained with some data for that. So to compensate for this overpowering asset, indispensability of knowledge possesses some less desirable properties, which are also: first, the knowledge or data has to be voluminous, so it has to be huge amount of knowledge or huge amount of data has to be there. It has to be hard to characterize accurately. Means sometimes data is such a way that we cannot directly get a value from there. We have to pre-process the data, we have to do lot of pre-processing or other segmentation or other virtualization of the data, based on which we can deal with this. Thirdly, is that it is constantly changing. The data constantly changes. When it is a real-time data, as the environmental conditions or physical conditions change, the data tends to change. So this leads to a lot of variation in data with which a intelligent system is has to able. Say today your boss is X, so you have trained yourself to based on the nature of X. Tomorrow your boss may be Y, so you have to work based on the nature of Y. Initially you'll be having some hurdles, you get accustomed, and then you work fine. So that is how we human nature deals with it, but the machine has to deal with it in case of the AI. The last is that it differs from data by being organized in such a way that it corresponds to the ways it can be better used. So you'll have data everywhere, but how you interpret the data is very important. So interpretation of data is the most important part here. So we are here to conclude that AI technique is a method that exploits knowledge that should be represented in such a way that: number one, the knowledge captures generalization. So it is not necessary to represent separately each individual situation. Instead, the situations that we share or the data that we share have important properties and they can be grouped together. Say I take the daily data of vehicles moving through the road, but what you can do, we can group the buses together, we can group the cars together. Now buses obviously are the public buses can be grouped based on the timing. If it's the same number of bus, it is coming after say 10 minutes or 15 minutes break or some particular. So if the knowledge does not have this property, then in ordinate amounts of memory and updating will be required. so we'll not be able to handle that. So we usually call something without this kind of thing data and not knowledge. Secondly, it can be understood by people who must provide it, or you can say the interpretation part. Although for many programs the bulk of the data can be acquired automatically from, say, instruments, from some instrument taking data and then we are applying it in the AI, in, or say if in healthcare we're taking data, applying deep learning and so on. In many AI domain, most of the knowledge of a program is must ultimately be provided by people in terms of what they understand. So just we'll be working as an interpreter, or we'll be using another program which can extract the features and do some interpretation. The main points here are: number one, it can easily be modified to correct errors and to reflect the changes in the world and in our worldview. Worldview means environmental knowledge and nearby knowledge, previous knowledge, past knowledge, and so on. It can be used in a great many situations, even if it is not totally accurate or complete. Third, it can be used to overcome its own sheer bulk by helping it to narrow the range of possibilities, means what is required, what is not required, and will regulate, say, no, we'll take the data only in the office time, will not be taking other time. Other times you don't get a bulk of the data, and so on. So, although AI techniques must be designed by keeping in this the constraints imposed by AI problems, there is some degree of independence between the problems and problem solving techniques. So, it is possible to solve AI problems without using AI techniques, such as we may suggest some solutions which are not likely to be good and so on. And it is possible to apply AI techniques to for solution of non-AI problems also, and it is likely to be good thing to do for problems that possess many of the same characteristics as AI problems. So we can regulate the AI problems. Now, in order to try to characterize the AI techniques in a problem in an independent way, as independent as possible, we can look into two very important problems, and we can go for series by step solving it and so on. So these problems will be taking up in the next class. It may be game playing, it may be card playing, and any other things. So thank you for your patience, and goodbye.